So good afternoon, everyone. I'd like to welcome you to today's webinar on the implementation of fault detection and diagnostics at the Scarborough Civic Centre. My name is Catherine Wilson. I am the program manager of the Mayor's Megawatt Challenge, a program working with municipalities since 2003 to reduce energy use and greenhouse gas emissions in their own facilities. As part of their mission to reduce greenhouse gas emissions, our member municipalities have said they're looking to get more out of their existing building automation systems. They're really looking to identify optimization opportunities as well as problems with the building systems. So the implementation of fault detection and diagnostics can help achieve these goals, as we'll show in the case of Scarborough Civic Centre, which we'll be discussing today. I'd like to thank our program sponsor, Enbridge Gas. I'd also like to thank Yorkland Controls for generously sponsoring this webinar and for sharing their expertise on the capabilities and implementation of the software. I'd also like to thank Intellisy for providing sponsorship for the technical panel discussion and for sharing their experience as an integrator of the software. The next slide shows our agenda for today. So we'll be looking at the capabilities of the software selected, things to be mindful of during implementation, taking a look at the savings achieved to date, and some of the recommendations for the City of Toronto going forward. The last 15 minutes of the webinar is reserved for questions from the audience. Next slide, just some basic instructions and housekeeping. So please use the Q&A option for questions related to the webinar content. Questions will be answered during the Q&A session at the end, but selected questions may be answered during the webinar, either live or directly in the Q&A section. Any questions we can't get to will be circulated in a question and answer document after the webinar. And please reserve the chat for any technology questions or questions unrelated to content. Next slide. So I'd like to introduce our webinar panelists. So just to let you know, this webinar will really be conversation style. Will be moderated by Amandeep Deol from Enerlife. Amandeep will be leading the conversation, asking questions to the panelists in the appropriate sections. I'll now ask each of the panelists to introduce themselves. Jerry, would you like to go first?
Yeah, thank you. Appreciate the opportunity to sponsor this webinar. I'm Jerry Salucci. I'm Vice President of Yorkland Controls, and as far as our connection with the software platform, we represent that platform for Canada, and we work through integrators such as Intellisys.
Great, thanks, Jerry. Again, I'd like to thank you for not only sponsoring the webinar, but for participating in our discussion today. Sahil, do you want to go next?
Yep, sure. Hello, everyone. First of all, thank you very much for inviting us as a technical panel member of this webinar, and myself, Sahil Patel, founder and CEO at Intellisy, and we are an integrator and value-added distributor for the Skyspark software. Thank you.
Great, thanks, Sahil. Thanks for sponsoring and for joining our discussion. And Ayo, you're next.
Hi, everyone. My name is Ayo Manyangole, and I'm a project manager building automation systems with the City of Toronto Corporate Real Estate Management Division. I am part of a small but dedicated group of BAS professionals who are responsible for developing, planning, and managing BAS capital projects in facilities that are owned by the City of Toronto. We also provide extensive technical support on all issues related to BAS to various divisions and business units within the City of Toronto. And one of our key mandates is to centralize our BAS operations while improving their energy performances. So we identified data analytics as another tool that we can use to meet this key mandate. And I'm looking forward to sharing some of the lessons we learned during the pilot project at Scarborough Civic Centre.
Great, thanks, Ayo. We really appreciate you taking the time to share your experience and bring the municipal perspective, and really looking forward to hearing how you're using the reporting to identify savings opportunities, as you mentioned, and how you're using this to support your commissioning process. So really looking forward to that. And last but not least, Amandeep.
Hi, everyone. This is Amandeep Deol. I'm a Director of Engineering at NLF Consulting. As Catherine mentioned, I will be moderating this panel. So NLF played a role with this particular project where we were the base consultant for designing the fault detection diagnostic software solution application for this project. So we'll be covering our experiences as well as trying to bring the experiences from all the parties to this, so we can address some of these benefits and challenges that currently a lot of folks are in the market for these kind of solutions and are facing. So we hope to address those through this conversation today.
Great. Thanks, Amandeep. And I guess now I'll turn it over to you to walk everyone through the project.
Thank you, Catherine. So
Thanks.
Thanks again for everyone for joining this afternoon. So I would suggest, in order to take the full benefit of this session today, please sharpen your pencil, and we have advised our panelists to address any of your questions that comes through. So I understand this is a topic that a lot of people, especially in industries, can relate to, and then we're hoping for that good conversation that could help address some of your questions and some of the lessons learned from this project that would help you implement some of these things at your facilities and organizations. So let's talk about the project overview. So I'm going to bring in Ayo to this. This was initiated by City of Toronto as a pilot project, as I kind of briefly mentioned, but maybe Ayo, can you give us kind of an overview of how it all started? What was the need that you guys felt for this to look for a FTD solution as a pilot for your facilities?
Yeah, so just briefly, we started looking into analytics back in 2018, I believe, 2018 or 2019. But we didn't really give it serious thought until about 2020. And we were looking for ways to complement what we were already doing with the BAS systems. We attended various webinars and looked at different solutions and different pieces of software that provide FDD and CMR reporting. And after very detailed conversations with several end users, we settled on Skyspark. But for sure, we looked at various options and reviewed the different options that are in the market. And we initiated the project in beginning of 2022 to try and see as a pilot, of course, because we'd never implemented this before, so we wanted to do it as a pilot to see if there's a business case for expanding it across our portfolio.
Nice. Thanks, Ayo. So let's continue that sort of discussion. So here are some of the goals that you initially set out in the RFPs. Maybe if you want to sort of touch base on what was near to your heart and what you want to accomplish through this software, as you sort of looked at many platforms out there, but there was common goals you're trying to achieve through all of this. And then Skyspark is one of the tools that it's out there for folks to consider. But overall, these were some of the goals that you were trying to address. Maybe you want to elaborate on that. What was critical for your organization as some of these goals are to be accomplished through this implementation or through this pilot?
Yeah, so as some of you may know already, the City of Toronto has a climate change initiative called Transform TO. So we wanted to develop business objectives that are aligned to the climate change initiative. So the first objective that we developed was to reduce GHG emissions and reduce energy consumption, and of course reduce the cost of operating and maintaining the BAS and HVAC system. The second objective was to improve the environmental comfort of the space. That's specifically space. We're talking about space temperature and humidity. And the third objective was to develop some sort of a way of quantifying the cost associated with the problems that are identified by the analytics. So we wanted to show through some kind of a dashboard that, let's say, if you have an HU operating during unoccupied hours, how can you quantify the cost associated with that unit operating during unoccupied hours? We thought that was important in terms of communicating the business benefits of the analytics. And the fourth business objective was to implement fault detection and diagnostics without duplicating the functionalities of the BAS. That was important to us because we didn't really want to overwhelm facility operations with more alarms and more trends to look at. And last but not least, we wanted to improve operational efficiencies and support the existing BAS preventive maintenance program through the implementation of corrective measures. And basically what this involved was preparing a list of recommendations on a monthly basis and reviewing those recommendations with facility operations, with the hope of working with operations to take actions to resolve those recommendations.
Thanks. Yeah, one of the things that I noticed when we looked at the goal, project goal, initially working with you guys is that understanding the capability of your BAS, ensuring that you're not doing the same task what your BAS is already able to do, and then duplicating those tasks. That was a key, I think, that we find as a differentiator in this goal scope is you want to use your BAS first to a point that you maxed out on whatever's the BAS functionality is, and then you look at the fault detection as another tool, as a means to achieve additional benefits for that. And the last piece that I sort of comment on Citi's approach is around making sure it's a closed loop, right? So your requirement to have a corrective measures documented and actions happening in that ensures that you get a software which as a tool helps you, but then you have a process as a CMR reporting and action that closes the loop on that software. So you're using that as a tool, but you're achieving your goals of minimizing energy use and increasing occupant comfort. So that's something to me was important for as a project goal to want to ensure that the software is used to meet an end results, which sometimes will get overlooked with these softwares. All right, so now I think the structure was pretty easy, but you still have to define roles as a part of the projects to ensure that the key stakeholders are aware of what their responsibilities are. Maybe you want to, can you talk about a little bit around initially what was the role for you for the consultant and what were your expectation? And also, to me, the most important, the piece in this puzzle is to work with the facility management, right? So how do you make sure through this process that you're continuously communicating with them, and also make sure that you're not adding extra work onto their plate, because that's something, as you know, is being challenged. Like facilities on their own, they have mandates, but you guys are acting as a support, right? Maybe you want to talk about that, how that your internal arrangement with your BES team and the facility management, and also with the integrated, how that whole functionality worked for you for this pilot project.
Sure. So let me backtrack a little bit and go back to the beginning of the project. So when we initiated this project, we did a fair bit of market sounding to get an idea of how the other end users were implementing data analytics, and we found out there was basically two approaches. One was to just go out there, buy the analytics software, install it on your network, and start configuring and setting up things on your own. The other approach was to bring in a consultant on board, hire a systems integrator to do all the heavy lifting for you, and that's the approach that we went with. So basically, the way we looked at this was, if you were implementing a major BAS capital project, chances are you would not go out into the market and just hire a BAS contractor to do the work without involving a consultant. You'd get an engineering consultant to do all the design work, create specifications, and all that kind of stuff before you go out to the market to get an integrator. So that's the approach we went with here. So we hired an engineering consultant, and the main responsibility of the consultant, and that was Enalife in this case, was to review site documents, perform design, create specifications document, do data collection and validation, do energy benchmarking, and of course, contract administration for the duration of the project. And so after we created all that, we finished all that design work, we went back to the market and hired an integrator to implement the software, perform the integration with the BAS system, implement all the rules that were created by the consultant, and get the system up and running. So after that, we needed to think about how to sustain the system. So a key part of sustaining the program was to have a group of application administrators on the City of Toronto side who were trained on how to use the various apps within the Skyspark application. So we obtained training for all the members of the BAS team to act as application administrators. And last but not least, we had to keep, as Amandeep mentioned already, facilities management is key to this, because they hold the budget for implementing the recommendations within the CMR report. But prior to that, we had to engage them, to help us with collecting site information, such as typical occupancy schedules and set points for the various functional areas within the building. But also, to make sure that they were not overwhelmed. So we made a deliberate decision not to actually expose them to the analytic software at all. So after this point, none of them has seen what it looks like, because we know they're already, they're busy enough, running around day to day, putting out fires and, keeping the buildings operating. So we took it upon ourselves to act as application administrators and only provide facilities with the list of actions that they needed to implement to correct the issues identified through Skyspark.
Awesome, thank you. That's kind of explained the whole process pretty well. So yeah, the defining the roles and responsibility early in this stage and getting that clarity is very, to me, it's important to get a successful implementation of the project, and assigning those roles and responsibility and having that initial stakeholder engagement with your different stakeholders to make sure that they're aware what's happening, what's going to happen in the next 6 months or 8 months as it get implemented, is very important for the success of the project. So this is the building that was shortlisted for the pilot project. Again, we'll go through the details of this in a bit in a few more slides, but basically it's a Scarborough Civic Centre 5-story building, around 372,000 square feet, built in 1973. Typical heating and cooling systems that you would find in a building. So majority of the systems were covered as part of the building automation systems and the fault detection diagnostic tools. So I'll just quickly run through a few of the slides. So what you see on this graph is it's the total energy consumption or a total energy intensity benchmarking chart for different city halls in North America. So when they're normalized and you compare that total UI, so the blue is each bar is one of the city halls, and the blue bar is your electricity intensity, and the orange bar is your thermal energy intensity. So when you look at, and these red lines which you see is the top decile, top quartile, and median energy targets for these facilities. When you look at Toronto Civic Centre, it is below the top quartile, which is 23.5. It's slightly above the top decile, which is 20.5. So this is, I think we generally tend to say this exercise should be performed for all of your buildings if you're considering those for your fault detection diagnostic software, because it gives you an idea where your building sits in relative to the other peers and when normalized to there, and also gives you an opportunity to understand what is the savings potential expected from this building if this building were to perform at a top decile or top quartile or median targets, right? So this to be is kind of a challenging situation. You would put a fault detection diagnostic services providers and the software itself to work on a building which is already efficient, like which is already below the top quartile target, and to target that building and achieve savings on that. It kind of tells you the application of the software and how it got implemented is have resulted in this in those additional savings, right? So if you had a building at the bottom of the chart, you would see definitely more savings from these softwares, but there is a merit to apply on the buildings that are already performing well. You could expect additional savings coming out of through this application. So again, just a kind of energy use background on this building. So this is when the project was started. The baseline was used 2019. So base electricity, if you've seen the previous mirrors webinars, you have seen this component energy analysis use. So basically it's electricity is divided into three components: base electric cooling, electric heating, and then the gas is divided into two components: base thermal and heating thermal. And then there's cost associated with each component. There's targets associated with each component. And again, these are top decile targets that will put the building pretty much at the top. Once these targets are achieved, they will put the building at the top of the benchmarking chart. So as you could see, there's savings potential on base electricity, which is basically your 24/7 load that's not weather impacted, like fans and elevators and plug load. And there's some savings potential on electric cooling, with a lot of savings potential electric heating as well. Similarly, less savings potential or no savings potential base thermal, and high saving potential or heating thermal, which is associated with how much outside air you bring in, and then the amount of heat needed to heat the building in the winter time. So overall, this was sort of the initial targets that were set for the building. But again, this is more targets to bring the building up to the top of the benchmarking chart. Now, these were the systems that were in the scope of work. Most of the systems, heating pumps, boilers, ventilation systems, cooling plant, all of the systems were considered for this type for FTD software implementation. So, and each of those systems had their own sort of rules, and which you will see a glimpse of those as we get to the other slides. So before we go into the actual project's details around implementations and the performance and what are some of the dashboards that were set in, I'm going to bring in now Jerry into the conversations around Skyspark itself, like, because this is one of the tools available to you in the market. There's other vendors out there as well, which associated with fault detection diagnostics. So most of the conversation we talk about fault detection diagnostics is going to be could be applied to different vendors as well. However, the application of these softwares are slightly different. The controls you get on some softwares are different. So we're going to focus on the Skyspark because that was the pilot that was used in this project. But definitely, if you have any questions in general about FTD softwares or anything that comes to your mind, please feel free to ask that question. So maybe, Jerry, you want to sort of give our audience an overview of the Skyspark and how long it's been in the market, and what are some of the basic functionalities that you see on the Skyspark as an FTD tool?
Yeah, thanks, Amandeep. So yeah, Skyspark is, as AO and Amandeep has mentioned, it's software only. You consider it as Microsoft, you buy it, and then you have to deploy it and try to maximize it. So Sky Foundry is the company name. Skyspark is the software. And globally, it's been deployed over 1.8 billion square feet. Our experience in Canada has been working through consulting engineers and other municipalities that are starting to pilot or various phases of deploying the software. Some have decided to take the skill set internally and connect to, and we'll talk about the different phases, I'm sure, excuse me, about how to implement this thing. But it is a very versatile software. It is a platform that has, as you can see by those icons on the right of your screen, different applications. I think IO mentioned that they have they have app champions, and Skyspark is more than just a fault detection tool. It's known as a fault detection tool primarily, but it does do energy comparison, energy intensity comparison. It has plugins to the portfolio managers and a lot of other greenhouse gas database reduction databases. Principally, it has the flexibility to have built-in rules or predetermined faults rules, as well as the ability to customize, where the customized feature, as that owner gains more insight into the operation of the building, the rules, so to speak, are not hard-coded. They can be modified or added to using as the life of the building or those energy conservation measures are implemented. They're typically adjusted by the user or the integration. The other, what I think personally is the advantage of Sky Foundry is to visualize the information that you're getting. So we're democratizing the information. This is, I guess, a case study where the software was applied to an automation system. So eventually, I'll poke AO and say, how many of his facility managers have actually sat in on a building automation system and see those turning wheels and trying to decipher what that automation and click on several screens to determine what's actually at fault, right? So fault detection in generally takes that information out and makes a rendering of, correlates the data so that it abstracts that and makes it the dashboards and the information more relevant to the user, whether that's the classical building operational technician or to the energy or the consultants that are operating on a project like this to enhance the operation of the building. So the dashboards are basically virtually out of the box, but then they could also be customized to the user. So hopefully that wasn't too much of a commercial there, Amandeep and Nail.
No, I think well, I know it's because since we're openly talking about Skyspark, we don't have any other option not to talk about Skyspark. So I know as a consultant, we are always vendor agnostic about these tools, but again, this is an application of one of the tools. We have to talk about Skyspark here. So.
And just so you know, right, this is self-plug. Yorkland as a distributor has access to other fault detection tools. And to be honest with everybody on the line, I mean, that we have an affinity for the software because of all the right reasons that is being deployed on this project. It's open, customizable, and it uses integrators that can be, many right across Canada and the United States that can be used by end users, and in this case, municipalities, to get a competitive project.
Thanks, Harry. Let's talk about just briefly on this the cycle. So I think this is one of the key applications or key questions that we see on these FTD softwares is around what happens if I fix all the faults, for example, that comes out of my Skyspark and now have a diminishing return on the software itself. Like why would I invest so much money into this and then find that I've already fixed the issue that software was telling me, and then I end up paying for the rest of my life of that asset. Like, can you, and I know we talked about this in the past as well, and we've seen different results, and it's a fair question that we get to see from the building owners and operators, right? But maybe you want to elaborate on how this sort of the implementation cycle works and what typically you see in this cycle as the software get implemented.
Yeah, so I would start this off by saying, again, it's just software. It's how you use that software and the resources required. In this case, the City of Toronto has got their act together with being able to use the tool in its full effectiveness. And you're quite right. Our early experience was that when fault detection, in this case, I'm going to talk generically, fault detection software is implemented, whether it's on site or in a cloud or a combination of both. The immediate expectation should be a reduction in the utility bills because you're starting to identify the low-hanging fruit when it comes to energy saving. So, for example, are the schedules all set up appropriately? Early days, we were able to identify, fantastic BIS system, all the schedules are set up. And, through no fault of any operator, an adjustment was made and all the schedules were changed so that there was, as an example, the air handlers were starting when there was really nobody in the space. So that stuff happens, and nobody would really know about it unless you had an overlaying supervisory fault detection system to point that out. So pumps running when they shouldn't be, scheduling, that kind of low-hanging example that I mentioned, you should expect, right? What I think people or implementers or people that are thinking about analytics would be, what can we look at to gain more insight from the system, whether that's looking at established rules, start looking at how the equipment is performing. You could have comfort, you can have people in the space being comfortable and not realize that both heating and cooling is on at the same time, that the chiller and the boiler are on at the same time during the shoulder seasons. So that's an example where it's not really a fault, the equipment is operating correctly, but there is an issue, right? The first stage, as I mentioned, low-hanging fruit, as the operators and the partners that are looking at just the fault detection project, you start getting that information lined up, and then you start realizing that you have probably some equipment issues. Example, dampers are stuck open. We're bringing in air and then we're reheating it or dehumidifying it when we shouldn't be. That requires a labor dollar value, a budget to the labor to go fix that damper. Are the sequences in the building automation set optimized, right? Why is the heating and the cooling coming on at the same time at 4 a.m, right? Which is an exact example that we ran into. So that's that bump there in the blue line where you should expect in budget some fixing of broken stuff, right? And then with that, you start looking at what kind of potential energy savings based on optimization. What routines can we start implementing that affect and provide some enhanced energy savings? So one of those would be, implementing ASHRAE Guideline 36. With those people on the line who don't know about it, it's a defined set of operating rules to optimize an air handler, VAV boxes, and boiler equipment. Just came out and it's been refined. So if you have a BIS system, I would encourage all of you folks to go ask your operations people to implement those sequences, because the rules and the faults are defined in that guide spec. I know I'm kind of got off track, but that's the intent of that guideline. Now, moving forward, you have, as I said here, you're looking at equipment, older equipment needs to be replaced. Now, the software should be starting to make a case for why you need to invest in new equipment. So as you progress, you start looking at maybe, investing in replacing older, less efficient equipment, justifying it, visualizing it, having a software tool that's able to identify which equipment might be out of whack, and start looking at how do we continually maximize with the equipment to implement some further savings by, and I'm sure Ayo will talk more about what the City of Toronto is looking at. But again, we're continuing to, what I call, less figuratively, milk the savings out of this system. And that can only be done by visualizing and making that information available to different skill sets within the operating or the building facility people.
Well, that makes sense. And I think our experience is similar. Like we understand the buildings are challenging, and then you have operations teams also change over time. So there are certain decisions that are made that may not reflect the high performance of a building. So this tool does help you to ensure that you get a continuity not in operation, but it also makes sure that that high performance is sustained over the years. So definitely it's a fair question to see what's my actual rate of return on this investment as you sort of fix those faults. But then we've looked at it carefully at other systems, is that overall there's always things happen in a building that sometimes negatively affect the performance of the building. So definitely there's a merit to continue with this software to ensure that you get the continuity and the savings are sustained over the years.
Yeah, absolutely. And these days after COVID, there's flexibility of office systems, right? Where you had a capacity, as the model of the building and the occupancy schedules of that change, you do want a versatile system and software that could capture those changes.
Absolutely.
So yeah.
Yeah, I think this is another question that generally comes up, is like if somebody were to look at Skyspark, and I think this is coming from your experience of working in different buildings across Canada. If there's an average building that needs 2,000 points, this is where the cost allocation for that 2,000 points is going to be, right? So maybe you want to quickly expand us to, and we'll cover all these phases through this actual example of the project, but maybe just want to on a high level touch base this.
Yes. Thanks for integrate high level, because I could get too deep too quick, right? So you keep me in check. So if you looked at all the blue lines there, that's the relative cost. If you add them all up, they should equal to 100% of the project cost. And our experience is that there's different phases of it. There's the audit, the scoping, and then there's connectivity piece, purchasing of the software based on points. It's a one-time purchase, and there's some maintenance fees associated with it. So it has to reside somewhere. It has to sit locally, on site, on premises, or brought into a server or cloud, however you define that. Then there's this connectivity, physically, generally more hardware required to get and suck that data from a building automation system back into the software. Then there's this skill set where we really rely on the systems integrators to do that. We're there to support them. And it's this whole phase 3 part, this importing of the data. At that point, I think Sahil will talk a little bit more detail. You're normalizing the data, making it relevant so that we're getting it out of the BAS speak into more of a method of keeping that information standardized across all building platforms. So an outdoor air sensor is the same, represented with the same data set right across, regardless of who the BAS vendor is. Then there are some generic rules that are applied. Those rules are, basically mathematical formulas that are applied to, the equipment. So simple mathematical formula is the intersect of X and Y. What does that mean? Well, when heating and cooling is on, that's a rule. Whenever heating and cooling on, we're going to create a visualization of that. Then there's this piece of validating. Do those rules, are they too sensitive? Or are we creating false issues with that? So that validation and testing all that out, that's part of what we call phase 4. Phase 5 is dashboards, reporting, user experience. It requires a little more dialogue with the users to see what exactly they want to see in rendering and making that information relevant to them. And then there's I call it training, but there's this ongoing informational discussion about how the use of the equipment. Those are where the insights are evaluated, and then further reporting and on-site training should be factored into. So it's the largest cost, as far as I'm concerned, for an average point system is the software, which is about 33 to 35% of the total implementation.
Awesome. And then we'll look into the specific cost of this project as well as we go through the slide. I think one of the things I want to mention, in addition to this, as I pointed out, there has to be a team set up to look at those CMR report, and we're getting the questions on that, and I'll bring that in a second. And thanks for people who are typing in the question. We'll definitely address. There's 2 came in. There's definitely good questions, and we'll address those as we go through the slide. All right, let me now get into the details of this actual implementation. So I'm going to bring Sahil here, who his team did the system integration for this software, and we're responsible for the connections, responsible for creating the rules, setting up the rules, and making sure the dashboards are as per the requirements of the client and all of those information. So we'll start with first on sort of, maybe Sahil, you wanna give an overview to the folks around what is the high level architecture look like for an FTD system?
Yeah, sure. So high level architecture, they're like as we can see on the slide here, it's divided into 2 parts here. In the first segment, we determine what sort of existing data sources are there on the site. It could be like a centralized building automation system, or it could be standalone controllers and kind of with some gateway, we try to bring that data in, and it could be like a different utility data, weather data associated with that particular site. So in the first segment there, we are just showcasing all the different data sources, and that data from left to right, there is a data flow that all the data coming into the FTD server and kind of through the virtual cloud connectors, virtual data connector, we can call it. And that's when in this Skyspark case, the database that is used by the Skyspark is the folio database that is originally developed by the Skyspark actually. And that's when the aggregation and normalization and kind of cleaning and pre-processing of all the data happens. And through standard hashtag naming convention, that's where we create the data model, which is basically we try to make the data ready for all the analytics. So the more tagging and the more normalization that's applied on the database, it's just becomes easier to apply the analytics on. And on the right side there, that's we're showing the analytics engine, which is part of the Skyspark here. And we can define, as Jerry previously mentioned, simultaneous heating and cooling and all that sort of rules that are specified by the energy consultant, in this case, Enerlife. So we can make all those calculations and define those calculations inside the rule, and then pretty much automatically analyze. A system will in real time automatically analyze all the data coming into system, and it will try to find detects the pattern to represent the issues. And based on those analytics finding, yes, go ahead.
No, sorry, no, complete. I thought I have a question. So yeah, go ahead.
So based on all the findings, like Skyspark helps us to generate the visualization, which are easy to work with and kind of send that message across the organization to act on that specific findings.
So for the on the left hand side is you're showing that you could have a different source of data. You could have utility bills, which could be in an Excel sheet. You could have a weather data from an external source, the website, for example. You could have the biggest source of the data you have is the building automation system, which is your trend logs that are either historically available through a database that are saved in there, or you could have the Skyspark could pull the data live as well. So you could set a frequency, for example, at 12 at nighttime through the connector, go get all the data that were saved on those controllers during the day, and then put that data into a database, which is a Skyspark database, right? Is that what happened on this site as well? You had the connectors that were continuously pulling that data through the building automation system because it's a BACnet compatible. So the connector is also BACnet connector that pulls that data on a regular basis and store that in the database, right?
Yep, true that. So in this particular City of Toronto's case, as city is using the FinchTech as their building automation management tool. So that is pretty consistent with the tagging as well. So we used a hashtag connector in this case particularly, and also for some of the other data. So yeah, that's explained on the next slide, that what different kind of connectors are available. And so Skyspark pretty much works with all different kind of data. As you just mentioned, we can have the real-time connection using the data connector like the BACnet IP or Modbus TCP or PC709, all those standard protocol. We can have the real-time connection, or in some cases, if the controller or the centralized supervisory system is storing, let's say, for a month worth of data, then we can have a periodic history sync without putting an extra network concession on the building automation server. So there are a couple of ways in terms of the communication protocol. If the system is not being able to communicate, or if there is no router that's sending that can send the data out of that server, we can have a local files in a CSV format that can be easily brought into the folio database and brought into the FTD server. Even in some cases, relational database like a Microsoft SQL server, we can have that's a standard out of the box connector that we can connect to those kind of databases as well. And external systems like utility data and weather station, where there are like API endpoint which provides the data, we can have the connection as well. For the utility data, the standard connector includes the portfolio, Energy Star portfolio manager. But that's not the limitation of the Skyspark tool. It's a truly open tool, right? So as previously mentioned, so what does that mean is we can even have like some custom connector that we can build upon our FTD system that have some sort of older system or which does not support any standard protocol. We can connect to that kind of system as well.
So
Mhm.
when the data comes in, so this is kind of takes us to the next step, right? So when the data comes in, now a lot of organizations have different building automation systems. So they could have Honeywell, they could have Johnson Controls, Siemens. The trend names are different in every facility. The way the trends are set up are different. Like you have a change of value, you could have a 15-minute interval, 5-minute interval. What happens? How do you standardize the trends that are coming out of the BAS so you don't have to change the rules every time because there's different names of different BAS companies how they configure. So what that standardization process looks like, and can you talk specifically about this project as well?
Right. That's 100% true. I mean, not even like the data type, but also the naming convention is not even standard across the different manufacturer calls the same point with the different, like a heating can be called HTG or heating full name and stuff like that. So naming is not standardized. So Skyspark is basically based upon, and the Sky Foundry is actually the original founder of this Project Haystack, and Project Haystack is basically the open source initiative to make work with the IoT data easy. And you guys can head on to projecthaystack.org website, which on that website, they include like entire library of the tagging that can be applied to the building automation system or any other data that's coming from the facility. And what that standard is basically it gives the meaning to all the particular points via tagging, and that semantic tagging is used in the building the haystack data model. So each and every point will have like a dimension, unit, relationships means how each points are related to each other. Association means how that point is associated to the equipment or any particular site where that point is located. So basically, by just looking at the singular point, we know what equipment belongs to, and so that kind of naming standardization and description standardization happen when we create the haystack data model.
So the rules are based on haystack tagging, so which means that
True.
once the point is tagged, then it's gonna see it could basically be used to apply the rules. So for any organizations that has, so this is a one-time exercise for you to normalize the tags for that organization. Once it's done, then you could have a standard rules that are already developed, and those could be applied because now your points are normalized with the tags, which are those tags are now taken into the rules as a consideration. So you don't have to change the rules all the time. You just tag the points, and then that helps you sort of define those, implement those rules.
Right, exactly. On the next slide, I think I'm mentioning it. So here we are giving this rule example, as Jerry previously talked about, the simultaneous heating cooling rule. So when we define the tags, when we define the rule, we are giving that rule a specific tag on which equipment this rule will run on. So for example, on the pilot, we have decided to run any specific rule on, let's say 10 different AHUs. And now, if we are adding multiple other sites and multiple other AHUs where there are, all we do is like add the tag with the AHU, and then this whatever the predefined rule was applied to, it will be applicable to that newly added equipment as well. So how good we are tagging and how good we are putting the information onto the point, that's what matters when standardizing the whole or streamline the whole rule implementation process, right? Because you're right, like it's not going to be like when you add multiple sites in, you will not need to add those rules again and again and again. It's just all matter of tagging while adding the new points in.
Yeah,
so,
and there was a question for the tagging as well. So do you have to manually tag the points first time?
Not necessarily manually tag the point first time, because now they're like Skyspark has this Axon programming language, right, where you can have a list of points, and based on that list of points, you can write some script to automate the process of tagging. But definitely, they're manually tagging all the points is Skyspark has a great UI to do that as well. But when you're working on the large scale project, that's not that's really a time consuming process. So in terms of automating that process, so we can take a two approach. Both approach are possible. So if you're adding just a couple of points and few points here and there, then yeah, definitely the UI can be useful. But yeah, automation can be done on that side.
Yeah, and my experience has been that it doesn't take a lot of time to tag it, because once you have 5 air handling units, if you tag one air handling unit, the same point's going to be applicable to the other units as well. So you could use that script of tagging it to the other HUs as well. So I mean, it's not a huge time consuming exercise to tag it, but the beauty is that when you tag your points, then everything downstream is set up based on those points already. Your rules are set up, your dashboard could be set up, your KPIs could be set up. So everything is set up based on a standardized structure, what you do is you just standardize your points to that structure, and everything else downstream is kind of standardized that. So next step, once you do that, sort of you apply the rules, what are the options for visualization to see how what is an outcome coming out of that? So now we're stage 4, where we originally started with stage 1. We got connectivity to the data, we store that data, then we apply the rules, and now we're looking at what we do after that. So can you maybe walk through a couple of applications that Skyspark has as a visualization?
Yeah, for visualization, these are like definitely there are other apps which represent the history and trend directly of whatever is stored in the database. But this is kind of once you apply the analytics and when you apply the rules, these are the out of the box application, like a Spark app, KPI app, Energy app, and GHG app. Spark app is pretty much so whenever you have any notification for the Spark, let's say, and when you click on that link, it's what this does is basically based on the tagging that you applied previously, it combines all the associated points, and it generates a pretty rich view to analyze that particular Spark with all the correlated and correlated points with it. It can also summarize based on the total duration, total occurrence of how many times that occurred in particular time frame that is selected, total cost of if we have added the cost, I mean total cost of that particular rule. And there are other rule you can add the roll up values to kind of aggregate. There are a lot of functionality in Spark app, to be honest. And
yeah. And then we'll show some of these as we sort of go through the next.
Right.
So the next is reporting and monitoring. So now you created the Sparks. Now the Sparks are showing up saying this is a fault. And the next thing now you do is report on it. So somebody could act on it. How does that functionality is being built into Skyspark?
So the one that we saw previously on the previous slide, step 4, there are like multiple different apps to kind of dashboarding, right? Now, whenever you are digging through, let's say like 10 different faults or 10 different Spark, and you focused on high impacting 1 or 2 Spark where you are focusing for your next MNV or CM report, where you want the system to be improved, and when you want to send that message to the maintenance team that this is the most impacting fault, the favorites app come into action, where you can pretty much save any view as a favorite. Out of the 10 Spark, you focused on that one Spark, and then you go on that fault, and then all the related associated data comes into that view, basically they call it. And once you have that, basically once you saved it under favorite, you can export it in multiple different formats to be included in that MNV or CM report that will go out to the maintenance team. And also for other Skyspark user or other FTD user that are within the organization, they can just view that favorite within one click. And this is just a reporting, right? But Skyspark is built upon managing the whole life cycle of the fault. So from the issue identification to resolution, basically the second app comes into action, which is called the ARC app. So where you can create the work order whenever the Spark is generated, create the tickets, add the notes, so what's the status of that particular fault, and as the fault is being resolved or as the action is being taken based on the MNV and CM report, you can track down that within the FTD architecture. So it's basically the Skyspark has a capability of expensive computerized management system, maintenance management system, or workflow software built into it. So that's where it helps reporting and monitoring. Yeah.
All right. The last
training.
step is the training, right? As you know, with any software, like it's built on a programming language. There are bits and pieces that if you haven't seen that, or if you haven't learned that, it takes a time, right? So how critical is the training aspect and the functionalities of folks who are sort of thinking about this? What do they have to consider as a part of their training for their staff, or even for the people who are actually looking at the faults and acting on them? What sort of training aspects are important for them to understand?
So yeah, there are because the Skyspark is community-driven software, right? So now there are like from even the Sky Foundry, there are multiple high-level trainings available on the tool. But as an integrator, what we focus on is we identify what kind of apps and what is the use case for a particular organization that's going to use this FTD architecture. And to effectively utilize those, we prepare the training curriculum that's focused on the team. And the training is basically the virtual training, instructor-led training, where we have divided the whole process of the implementation in the different segment, where it starts with collecting the data from site and getting connection with the connectors, separate training for the data tagging models, and a separate segment for applying the rules, and also one more separate for the creating visualization and stuff like that. So after training, we aim to provide detailed documentation on how to use this tool effectively. So once they get using the tool on a daily basis, they kind of think of an advanced pathway for the training on how to utilize the tool more effectively. So that's the training.
That makes, I think, yeah, the training is a key piece
Training
into
is
it. Let me quickly run through a couple of slides as we these are also important. So as you could imagine, when you have a few hundred rules set up in a building, and then you would see on a Skyspark this kind of a sort of one of the dashboards is around these rules will trigger, and then you probably when you're working with your team, you would have to focus on prioritizing these, because not all of them you could tackle at one time. So there's many ways to prioritize these. Like you can prioritize based on how often they happen. You can prioritize based on the cost associated with each of the rules. You can prioritize based on a particular AHU. You can prioritize based on a particular wing of the building or a building. But prioritization is a key. So you don't get you have your structure set up within an organization to how to handle these sparks, as there is going to be many initially. But as you go through them, fix these issues, and reduce that list, you will find that it's going to get more manageable, and the prioritization is going to help. Here's some of the examples I'm going to share with in terms of the rules that were set up for this building. So one of the rules, easy ones, was around the scheduling. Like if I have this is my fan schedule, give me a rule that tells me when my fans are running beyond the schedule. So what you see on this is the list of the AHUs and number of hours they're working in addition to their schedules, and then the cost associated with them. So you sort them with the cost. This is information that we'll talk about in a second with IO as well. This is information IO used to bring it back to their facility folks and ask them about, okay, so we settled originally on this schedule for this AHU. What are some of the reasons why we're running this at a higher schedule? And most of the times the facilities folks have answered to that, but sometimes it's more of a conversation to make that change, so you start to see the savings appear as well. And but this tool helps you identify these issues right away. So you can look at it on a weekly basis. You can also look at it on a daily basis, on a monthly basis. But it gives you an opportunity to quantify the savings and to quantify the issues pretty easily through these dashboards. Again, another rule on the outside air tells you how much outside air are you bringing in as above the ASHRAE 62.1 requirements when the system is not running an economizer. So again, gives you an opportunity. It's related to your heating thermal load. When you do the benchmark component analysis originally with the building, and if you see you have a high heating thermal load in the building, this is probably one of the reasons why you had a high heating load, is you're bringing too much outside air into the building. And then this rule exactly tells you how much are you spending on a daily basis or a cumulative basis to on bringing too much outside air into the building when it's not needed. We're just covering a few examples of the rule just to kind of give you a very high level picture of these to get an understanding how the Skyspark tool looks like. But if you have more questions or we want to sort of understand it better, you always feel to welcome any of the panelists here to contact them offline. So another rules, the condenser pumps, they were running when the chiller was off. Simple things to just talk to the operator, turn them off, and you have all the savings from this pump. AHU monthly, so another example of a dashboard where virtual meters was created for these dashboards for each AHU, so you can see how they're sort of working on a monthly basis. And you could see, here's an example of one of the systems, AHU5. It's on average, you can look at it, it's sort of this is done on a cost basis. You can also do this on a kilowatt hour basis as well. You could see the last 2 months, I think this is February and January and February, the consumption went up, which means that the systems the schedules have been changed on the systems, and that's resulting in increase in the consumption. Similarly here for AHU9, you see a high increase in the consumption in the last few months compared to the rest of the months. This kind of gives you a virtual dashboard. Again, it's pretty flexible. You can have your own dashboards as needed. Another dashboard was weekly reporting, which again tells you a summary of the synopsis of a week, that these are the faults in that particular week, and these are the associated trends. So if you have a dedicated team on this, they will look into this, then confirm what's an issue, and then bring that issue back to the facility team to fix it. So in this case, there were some functional issues with the BAS, the command not matching with mismatching with the status, and then fans are underperforming. Some of the rules were triggered as for this particular week. There's dashboards again done on a monthly utility consumption analysis. When you're doing a M&V, you could have a baseline set up using regression analysis, variable, single variable, multivariable, and those baselines then track against the actual performance. As you could see then, for this particular month, you could see that the savings, the prediction is the blue line, the measurement is an actual. This is the savings that appeared once the measure was implemented, sort of the mid-month in this example for this particular system. I'm going to bring Ayo into this conversation. There was a question asked around the CMR reporting. Let me read that question, Ayo, to you, and we can quickly address. So just a background. So this is the corrective measures report that gets generated based on the faults. Then this report documents the estimated cost savings. It also documents the recommended actions that facility team needs to take, and then also associated with the target completion days and the status on that. So maybe Ayo, if you can sort of elaborate how you're currently using this process, and what are some of the sort of lessons learned that the CMR reporting help you to have a conversation with your facility staff to implement these measures. Because the key, as we suggested, the fault detection diagnostic is just the tool. It gives you information, but you need people to act on it to make those changes, right? Maybe if you can sort of provide some insights into this.
Yeah, so just briefly, the CMR is key to this process because it's how we track the actions that are being taken against those recommendations. And a key part of that is estimating the cost savings associated with each recommendation. And in this case, we went with the low-hanging fruit of AHU occupancy. So even though this is information you can probably extract from your BAS, we wanted to go a step further and quantify what the cost savings could be if we modified the schedules based on the recommendations. The BAS will not go as far as providing you with with a cost with an amount to give you an idea of how much you could save if you acted on the recommendations. The second item that you have on the list there is related to static pressure controls in the building. And really, a lot of these recommendations were very basic, and we were able to implement most of them remotely without even having to go to site through basic programming changes. It might look simple, but the cost savings are quite high.
All right, thanks, Ivan. Yeah, I think this is the most, to me,
Sorry,
this is
let me add one. And let me add
Yeah,
one
sure.
thing. So because at the City of Toronto, the BAS group doesn't directly operate and maintain buildings. A lot of these changes involve a lot of conversation with facilities. We had to negotiate with them and try to convince them to change the occupancy schedules on some of these units, because if they change, let's say if you have a unit that is supposed to run up to 9 p.m., if we try to convince operations, let's say, to shut it down at 7 p.m., that could have an impact on in terms of how they relate to building occupants and the tenants within the space, right? So it's not as straightforward as just going into the building and changing the schedules. There's a lot of negotiating that has to happen with facilities. That might be different for other municipalities where facilities operations themselves could be considering implementing data analytics. In that case, they would have full control over the occupancy schedules and over many of the maintenance activities that are recommended through the analytics software.
Thanks, thanks, Harry. As you pointed out, this is one of the critical aspects of the success of the project relies on how effectively you can implement the CMR reporting and how effectively you can manage the facility teams to make sure that they're on the same page when this is applied. Okay, here's some the savings results that as a result of the implementation. So what you see on the left-hand side top graph is a chart starting from January 2022 to February 2024. Blue dots is the actual consumption at the meter for electricity, and the red dots are the normalized baseline used for this exercise. So starting when the implementation period started, as you could see the slow implementation of these measures, you could see the savings appeared to date, and then there's some months where, some months the savings decreased and the consumption actually increased and it went back. So again, these are some of the key areas where if the fault detection hadn't sort of came into existence, you wouldn't have easily noted this change, and then the consumption would have continued to increase over the next period. But there was some action taken and the consumption went down, and then still there's still work need to be done. As you could see, the biggest savings were happened in these months of March, April, all the way to October. But then the savings deteriorated as systems changes were made on HUs and others to that effect. So on an average, as you could see in these months, there are higher savings around 12 to 14%, and the savings dropped to 5 to 3% in the last few months, maybe. And the similar trend on the gas, as you could see, the blue dots is actual meter consumption. As implementation started, the savings appear. The summer, there's no consumption. As we start in the fall and the winter, the savings appeared back in the system. But as you see the trend between January and February, because of the programming changes, you could see that the systems have gone back. Maybe you want to sort of kind of add your comments to that and how you're sort of responding to this kind of reporting, and then looking back and using the tool and figuring out what other things need to be done now to bring this facility back to the savings that were achieved initially in that original phase of the project.
Sure. So I think this slide here is a good demonstration of some of the lessons you learn when you do a pilot project. So one of the lessons we learned is that running an analytics program requires having dedicated resources to monitoring and managing your CMR. So I was a little bit hesitant if we should show this, this graph here, because my boss is on the line and he's looking at this and thinking, oh, why did the energy consumption go up through this month? But for sure, it's it's a good indication, because that's the whole point of the analytics. It needs to flag some of these anomalies, and it needs to to show you when you're not going in the right direction. So for sure, we'll go back and look at some of these numbers and see how we can make further adjustments to bring the savings back in line with the initial projections.
Absolutely, and I think the beauty of the tool is that you already have the system set up, so you would know from some of the dashboards that we previously shown which systems were contributing to this additional cost, and then you can pinpoint pretty easily within like few minutes to know where the issues are, and then you can go back to facilities and ask them the question, what happened here? Can we have a conversation around these systems where we did see an increase where the other systems are performing as they were supposed to?
And that really is the beauty of the analytics, because it gives you the ability to do that diagnostics at the system level. You're not just looking at the building level energy data.
Absolutely. All right. Financial summary. Again, thanks, Tayo, for sharing this. This is a lot of people have questions around, okay, this is all good. Tell me the numbers, like tell me what is my payback, tell me what is it. So this is here. So do you want to talk about that a little bit?
Yeah, so I'm not here to sell Skyspark or any other analytics, but what I can tell you is we have achieved these savings with minimal effort, because as I mentioned at the beginning of the session, we are responsible for planning and delivering capital projects, and this so we get very busy with other projects. This is an initiative that we came up with as a pilot, so we haven't really dedicated a lot of resources into managing and implementing the recommendations with within the CMR. So these are savings that we have achieved with minimal effort, and I have no doubt that if we dedicate more resources, the savings would be way more than double what we're seeing on the screen. So we are generally happy with the savings that we're seeing with the minimal effort that we put to realize those savings.
Absolutely. I think you pointed that correctly. Is this is again a tool. It gives you all the data insights, but in the end, you got to put resources to make those changes happen in the facility. You got to have contractors sometimes involved to make those changes. So once you do that, then yes, savings materialize. In this case, the overall, as you say, is the payback for this 1.3 years, but it's going to improve once all those implementation that are identified and they're implemented. Maybe generally you want to talk about how you sort of in future look to use some of these analytical tools and softwares for helping commissioning process in there. This is a unique take. I understand you guys are considering at this point, right, for these tools, given that the pilot worked out well for you guys.
Yeah, so two things really that at a high level, two things that we're looking at in terms of the next phase. Number one is to integrate data analytics into our preventive maintenance program. We didn't do that very well at Scarborough Civic Centre. At the beginning, we envisioned a process where we would work with the BAS maintenance contractor to implement those recommendations on a monthly basis, but it wasn't as easy as we thought it would be. And the next phase will be to integrate it into our commissioning process on ongoing BAS capital projects to support the commissioning process. Not to replace contractors, but to support the commissioning process.
Additional source. What I know is like it could actually help you cut down a lot of the time on the commissioning side, and also help you to get a better results from day one, rather than sort of monitoring that equipment 6 months down the road and checking on what's happening with my performance. At least this tells you this is my schedule. This is your system is running 5 hours greater than the expected schedules on this as a starting point, right? So it gives you those like.
And if I can add to that, so when you do a BAS capital project, your commissioning process usually involves looking at a system at any given time. So let's say you have a commissioning agent coming in to do functional commissioning. They're testing a system, at that instant. But the analytics, will basically do continuous commissioning. You may get a report from the commissioning agent today that says everything is working well, but you don't know what's going to happen tomorrow, and that's where the analytics will come in. It will continue that process.
Yeah, if we can add to that, this is more targets toward performance commissioning versus functional commissioning. This doesn't replace your functional commissioning, but this adds to the performance commissioning to ensure that your systems or your schedules and your sequence of operations are working as intended. And then to your point, it's not a snapshot at a given day or a given hour or a given minute. This gives you a continuity of days and weeks and months of data that you can clearly see how the pattern and establish that continuity to make sure their systems are performing as intended in the original scope of work. All right, let's dig into some of the lessons learned. Again, I'm going to bring you in. So this, and also Sahil as well into this is, what were some of the initial challenges on the implementation? I know I want to leave some time for the Q&A, and sir, everybody in the lines, please feel free to type in your questions. We plan to address them in a few minutes, but it will give us some time if you want to type those questions, so we can read it and address those. But Sahil and I, do you want to sort of share a couple of lessons learned that will be interesting to other folks?
Yeah, I can go. I can go first. So a couple of things. I'm gonna keep this really brief because I know there's always questions about how to get started if you haven't done this already, and how do you build a business case. Maybe I'll just focus on the business case, and convincing your senior management team or city council to provide funding. What I would suggest is develop a business case that is brief and really targeted at energy saving and things that you can quantify. And your engineering consultant, if you use the same model that we use, your engineering consultant can help you with the calculations for estimating the energy saving, because we know ultimately, what everybody cares about is dollar amounts, right? So you need to be able to quantify some of the business objectives that you lay out in your business case. And also importantly, I think it helps if you can connect those business objectives to some of your organization's initiatives or divisional objectives. Like in our case, we connected it to Transform TO. So it doesn't look like you're trying to do something in isolation. Whatever you do needs to be connected to your business objectives. And of course, as we mentioned earlier, you want to be able to work very closely with facilities to ensure that your recommendations are being acted on, because ultimately it's not the analytic software that will get you where you want to be. It's the actions you take to correct the deficiencies identified by analytics.
Thanks. I'm going to tag one question that came in around obstacles from IT department within your organization, because this software could be hosted outside, could be hosted on a cloud, or could be hosted internally. Can you address that? Was there a concern regarding data sharing? And I kind of know the answer, but I want to hear from you on how did you tackle that IT challenge that sometimes a lot of the organizations have, is sharing that data and having that connectivity from outside?
Yeah, so for any contractors who've done work considered on a BAS project, they'll know that our centralized BAS systems are connected to the City of Toronto corporate network. And obviously, anytime you connect a system to the corporate network, there's going to be restrictions in terms of, how you share data externally. So that's one of the reasons we specified a solution that could be hosted on premise. On premise in this case, meaning within the City of Toronto corporate network, not necessarily at Scarborough Civic Centre, in order to ensure that we could create a connectivity to our BAS database without getting outside. Obviously, we also have the option to eventually go into the cloud if necessary. But we made the choice to host it on premise to make sure that we wouldn't be running into too many issues with our IT group. But obviously, there was still one major issue that we had to deal with, and that was the part where we have to acquire the weather data externally, because for Skyspark specifically, the weather data comes from the Sky Foundry, and that requires going outside of City of Toronto corporate network. So we've had to work with IntelliSea to provide us that weather data manually on a monthly basis as a CSV file.
Cool. Again, we'll talk about. There's a few other questions came in regarding costing. I'll address those, but maybe generally, I think in terms of the recommendations, I do want to touch base, and I'll also touch base on that as one of the. I'll start probably, and then I'll bring you in. So one of the challenges, one of the things that we noticed, like what we saw during the implementation phase, was the lack of air testing and water testing results on the buildings, which sort of hindered some of the fault implementations, where we didn't know what should be an actual high performance value for static pressure set point, let's say, or for HU or differential pressure set point for a pump systems, right? So the one of the recommendations that came out of that was to ensure, if you want to sort of have best use of the fault detection, make sure you do that air and water testing ahead of time, so you get those values that could be used as set points to sort of calibrate to the high performance building. Do you want to add to it?
Yeah, so I think the recommendation you described there is like a best case scenario, but as we all know, in most facilities, when you walk in to do a project, you want to have an air balancing report sitting there waiting for you, right? So we really had to work with what we had, and that's one of the reasons where we kept our project objectives small and specific, because we didn't want to get into any major systems upgrades or any major air testing and validation within the building, because it would just take the project in a direction that wouldn't support the business case that we sold to our senior management team. So you want to make sure that you keep your project goals and objectives specific, realizing that there's other constraints within the building that could affect your project.
And these are some of the other recommendations that you've offered, right? So and anything you talked about, buy-in from facility operations teams and documentation on the occupancy, HVAC hours of operation. Those are all critical things that you want to know beforehand. It helps you sort of speed up some of that process, because now you're ready with that information. Once the Skyspark is built in with those functionality, you can start seeing the fault detections. I'm just going to use, actually we're at the end, I'm just going to use last sort of 4 minutes to answer some of those questions that came in. But if you have any final thoughts, Sayo or Jerry or Sayo, to comment on, please feel free to do that. And Catherine, do you want to take on the questions?
Are there any particular ones that you think best to answer live? Otherwise, the rest can be answered in a Q&A document if it's a little bit more
Sure.
specific, that might be better
Yeah, I
to be
think
written.
one of the questions that came about was generally there's 2-3 questions about costing, like how is the costing done on these measures. So I'll give you a few examples on that. So for example, on a fan that's not meeting a schedule, the costing is basically done as you look at the fan kilowatts when it's operating, the corresponding VFD speeds, how much kilowatts it's using. And then the fault, what it does is, let's say after 5 p.m., the system was supposed to shut down, but the fan continued to run for another 2 hours. What it does is then the virtual meter looks at those 2 hours, which accumulates the kilowatt hours for that fan based on its kilowatts. And then it adds and then apply the cost to it to calculate, apply the cents per kilowatt hour to calculate the actual cost for that fault. Similarly, you could do that for how much outside air you're bringing into the system. So if you look at outside air percentage formula based on the return air, outside air, mixed air temperature, you can calculate the outside air ratio that you bring in on every system, and then you multiply that with the CFM of the total system volume. That gives you the volume for the outside air. Then you look at the delta T between the outside air and the supplier temperatures to calculate the energy you added to that system. And that is what, and then you convert that energy into the meter cube of gas, and then you apply the gas rate that gives you the cost for that. So there's many other similar rules that you could use to calculate the cost for each of the systems. And then there was a question about how do you sort of see the cost application changing as the rates of utilities changes. Again, system gives you flexibility to input those rates as the rate changes throughout the months or the years. Anything else, Catherine? We have a couple of minutes. Io or Jerry, do you guys have any other final thoughts, comments, or Sile, anything to address?
I have one, maybe for the city or for Telesis. Was there a cost avoidance report that came up? In other words, we corrected it, we found the issue in a day, we corrected if it left, it would have cost so much over the period of time in a traditional system that wouldn't have a fault detection system?
Can I answer that? So yeah, we haven't we got the final recommendations from the consultant. That was months ago, but obviously right now things look a little bit different because we've had a few more months to run the system. But in any case, all of that would be internal. It's not something that we'll be sharing publicly. But all I can say is that the numbers look good.
No. What I was meaning to say was the tool itself being able to represent the cost avoidance, or was it just a generic report that was done, behind the scenes by the consultant?
So for the tool itself, maybe Sahil can elaborate on this. So the cost that you're looking at on analytics is not revenue grade. We're not using revenue grade meters here. All we're doing is trying our best to quantify some of the potential savings in order to facilitate our conversation with the decision makers, so we can obtain the allocation of resources to implement the measures that are recommended. But of course, you can also see the savings on at the building level when we do the the monthly comparison with the utility data.
All right, I think we are almost at the time. Thank you, panelists, so much for your time today. This has been a great conversation. I'm sure there's some questions. We will definitely address those through a document. Catherine, I'm going to pass on to you to take the last couple of slides.
Yep, sure. Thank you so much, Amandeep, and thank you so much to all of our panelists. We really appreciate you taking the time to join in today's conversation. I think there's a lot of useful information here. As mentioned, we'll circulate a question and answer document with responses after the webinar. Looks like the remaining questions will be maybe even better answered written. So we'll circulate that as well as a recording. Just to let you know, we have some upcoming events webinar tentatively scheduled for May 22nd. You should be receiving invites shortly on measures to start your net zero journey. And we have our next member networking session coming up on May 29th. So stay tuned for details on that session. It'll be coming out soon. And of course, there's my contact information as well as Jillian's. If anyone will also share the contact information for our panelists in the Q&A document. If you have any questions for them, please feel free to reach out. As always, thanks again, everyone. Thanks again to the panelists. We really appreciate it. And talk soon, everyone. Take
Bye now.
care.
Yep,
Thank
bye.
you.